Welcome to Ask and Learn.
Hello friends, as shown in the figure, there is a test trick was developed to perform fatigue testing on fitness trampolines. A motor drives the 200 mm radius flywheel. The radius of the flywheel AV is given 200 mm, that is 0.2 meter, which is pinned at its center point in counterclockwise direction with constant angular velocity of AV is given 120 rpm or 4 pi radian per second in counterclockwise direction. The flywheel is attached to the slider CD by 400 m connecting rod VC. The length of VC is given 400 mm or zero point 0.4 meter, having the mass 5 kg, and the mass of the link CD is given 2 kg. At the instant when theta is 90 degree as shown in the figure, we have to calculate reaction at C. Let us start performing it. Here we will draw the geometrical figure. This is the flywheel AB. A, B, and C. This is the geometrical center of BC or center of mass. This is given 0.4 meter and this is given 0.2 meter. Free body diagram of CD. First we will draw the geometry which has to be used. Position vector of B with respect to A will be 0.2 j cap meter. Position vector of C with respect to B is 0.4 j cap meter. Moment of inertia of BC about its center of mass 1 by 12 MVC L square VC. So it can be written as, substituting the value, mass of VC is given 5 kg, length of VC is 0.4 square. So it can be written as 1 by 15 kg meter square. Now we will draw the free body diagram of CD rod. Free body diagram of CD rod. This is C point having the reaction in Y direction and along X direction. This is the geometrical center of mass. It having mass of CD into acceleration of CD along y-axis, and here is the force Fx. If we find summation of force along y-axis, then it will be minus, its weight will act here, minus 2g minus 2y 2a series. This is equation 1. Free body diagram of VC rod. Cy Cx Vx Vy. This is geometrical center of VC. If it having acceleration MVC, xy, and the rotation in clockwise direction, so it will be IVC into alpha VC. Now, summation of Fx can be written as Cx plus Vx to be mass of rod VC into acceleration of center of mass in x direction. So from here we can write Px to be mass of VC is 5 kg, acceleration of VC minus Cx. Say equation 2. Summation of Fy, you will get Cy plus Vy minus 5g to be equal to 5 into acceleration of Vc along y-axis. Say equation number 3. Taking moment of force about g, that must be equal to minus 0.2 Cx plus 0.2 Vx is equal to IVC into alpha. So it can be written as minus 0.2 into Cx 0.2 Vx is equal to alpha Vc upon 15. Say equation number 4. Now velocity of V point we can measure. Velocity of A plus angular velocity of AB cross cross vector of position vector of B with respect to A. Velocity of A is 0 plus omega AB k cap cross 0.2 j cap. Omega AB is given 4 pi, so it becomes 4 pi into zero point 0.2 minus I cap. So we can say velocity of V point is minus 0.85 I cap. Now velocity of C point, we can write velocity of V point plus cross product of angular velocity of Vc with position vector of Cv vector. Substituting the value, Vc is along y-axis only. You may write Vc j cap. Velocity of V already we have calculated minus 0.85 I cap plus omega Vc is 4 pi k cap cross 0.4 j. So this can be written as minus of 0.85 plus zero point 0.4 omega Vc. Sorry, I have written wrongly here. This is omega Vc. So you can write omega Vc is equal to minus 2 pi radian per second. Now acceleration of V point can be written as acceleration of A minus omega square AB RBA vector plus cross product of angular velocity of Vc with position vector of Cv. Substituting the value, you may write acceleration of V point will be, this is 0, omega square AB into RV. Alpha Vc is 0, omega AB is 4 pi square and Va is 0.2 J cap. So this can be written as minus 3.2 pi square J cap. Now acceleration of C can be written as acceleration of V minus omega square Vc into position vector of Cv plus alpha Vc cross RCV position vector. Acceleration of C along y-axis, we can write acceleration of V already we have calculated minus 3.2 pi square J cap minus 1.6 pi square J cap alpha Vc K cross 0.4 J cap. So we can write minus 0.4 alpha BC I cap minus 1.6 pi square plus 3.2 pi square j cap. So on equating the x and y component, we can say alpha Vc is 0. Fifth equation, and acceleration of c is minus 4.8 pi square. Equation number 6. Now acceleration of Vc, acceleration of v minus omega square Vc, position vector of center of mass from V point plus cross product of alpha Vc with position vector of center of mass from V. Since alpha Vc is 0, so this term becomes 0. In component form, left hand side can be written as ABC x I cap ABC by j cap is equal to acceleration of V minus 3.2 pi square j cap minus 0.8 pi square j cap. So acceleration of Vc along x-axis is 0. Say equation number 7, and acceleration of Vc along y-axis minus 4.0 pi square meter per second square. Equation number 8. Using equation 6 and 1, we will get Cy. Using equations 6 and 1, we will get value of Cy 75.128 Newton, and using 2, 5, 7 and 4, Cx is equal to 0. So reaction at C point, you will get 75.13 Newton along y-axis. That's all for it. Thanks for watching it.